Hello students, welcome to Anne's classes. Let's do sets chapter 6, exercise 6a. Page 74, question 10, first one. Are the sets A and B disjoint? The question is, are the sets A and B disjoint sets? What's the meaning of disjoint sets? Disjoint sets are two sets in which not even a single element is common. Okay, so we have to find out whether, now set A, we already know what the elements are. Set B, we're going to find out what the elements are. So let's write down set A. Now set A, we already have the elements 4, 5 and 6. Now set B, we're going to find out the elements of set B, and it's given to us as x is such that x square minus 5x minus 6 is equal to 0. So we're going to solve this part. We're going to solve this part and we're going to find the value of x. So to find the value of x, we write the quadratic equation x square minus 5x minus 6 is equal to 0. Now we learned this in the previous video also. Now when you have a quadratic equation and you need to solve for x, what you have to do is look for two numbers which when multiplied give you minus 6 and which when added give you minus 5. So let's first look at numbers that give us 6. So that is 1 into 6 is 6. What about 2? 2 into 3 is also 6. But here we need to get minus 6. So this has to be minus 6. That means one of these numbers, 1 into 6, one of these numbers should be minus, or one of these numbers should be minus. Now two numbers that multiply to give us minus 6 are these. Now they should also add up to give us minus 5. So they should add up to give us minus 5. So let's write down now to get minus 5. I can take the first two numbers here, 1 and 6. So if I say 1 plus 6, I will not get minus 5. What will I get? I will get 7. 1 plus 6 is 7. So to make it minus 5, I can change 6 to minus 6. So now 1 minus 6 is minus 5. So I'm able to get this. So I can use the numbers 1 and minus 6. I don't even have to check the other two numbers, because when I add up 1 minus 6, I get minus 5. When I multiply 1 minus 6, I get minus 6. So now we are going to use 1 and minus 6. So these are the two numbers, 1 and minus 6. We're going to use these two numbers here and we're going to split this term. 5x minus 5x, we're going to split it into plus 1 minus 6. So let's write everything else as it is. So here we have x square plus 1x minus 6x minus 6 is equal to 0. So here we have split minus 5x into this, because even if you simplify this, you're going to get back this. Now we have done this so that we can get some common factors. So let's take the first two terms here and the next two terms here, and then let's see what we get. So here I'm going to take out the common factor from both. So x is there in both, so I can take out x. So if I take out x, now one x I've removed, so there is one more x here which I need to put here. So let me write it here, x plus, now here I have 1x. The x I've already removed and it's here. So now I have only one left which I can write here, 1. Now I'll go to the next one. Now what is common here? I have 6 that's common, so I can write 6 outside. So 6 is outside. Now inside, what do I write? I have minus 6x. In that minus 6, I've taken it out. So I only have to write x inside. So this is x. Now here, the next term that I have is minus 6, which is already here. So if it is already here, minus 6 into what will give us minus 6? Into 1, isn't it? So plus 1 into 1 will give us. And this is equal to 0. Now let's look at both sides. Now here I have x plus 1. This side also I have x plus 1. So let's take that out first. So I have x plus 1. That's common. And I also have x minus 6. So let's write that down. X minus 6, and this is equal to 0. So when you have factors like this, it means that x plus 1 is equal to 0 and x minus 6 is also equal to 0. So here x plus 1, I'm taking only the first one, is equal to 0. That means I can find the value of x. X is equal to 0 minus 1. X is equal to minus 1. So x is equal to minus 1. So I have found the first term of set B. Now let me take the next part here, that is x minus 6 is equal to 0. That means x is equal to 0 plus 6. That means x is equal to 6. So here I have my element here. So I have found the value of x here, x is minus 1 and x is 6 also. So these two are the elements of set B. So let's write it down here. So set B is equal to minus 1 and 6. Now can you look at the elements here? You can see that 4 and 5 are not here, but 6 is here. So here the question is, are the sets A and B disjoint sets? No, they are not disjoint sets because they have one element in common. So you can write the answer as no. Okay, because they are not disjoint sets, they have one element in common. The second one in question 10. Are the sets A equals B, C, D, E and B is equal to X such that X is a letter in the word master? Are these two sets joint is the question. So first let's write down all the elements of set A which is given to us. That's given to us is B, C, D and E. Now B, we are going to find out the letters of the set of the elements of set B. X is a letter in the word master. So let's write it down. M, all letters, each letter to be written separately. M, A, S, T, E, R. So everything can be written. Nothing is repeated. So we can write all the letters. Now the question is, are these sets joint? Are they joint sets? So what are joint sets? Joint sets or overlapping sets are sets in which there is at least one element in common. So here B, C, D, E and here M, A, S, T, E, R. So we can see E that's common. So these are joint sets. We call them joint sets. So the answer is yes, because the question is, are they joint? And we answer it and say yes, they are joint. State whether the following pairs of sets are equivalent or not. Now, what are equivalent sets? Equivalent sets are two sets in which the number of elements are the same. That means if A has 5 elements and B has 5 elements, then we call them equivalent sets. Even if the elements are different, if the number of elements is the same, they are equivalent sets. That means first we have to find out what are the elements of set A and then find out the elements of set B and see if they have the same number of elements. So first let's look at set A. So set A here it says X is such that X belongs to natural numbers. That means all the elements here are natural numbers. And look at this statement carefully. Now we're talking about X. So 2X is less than and equal to 11 and 2x minus 1 is less than and equal to 11. So we have to keep that in mind and solve it. So let's write this part here and find the value of x and get all the elements of set A. So let's write that. So I'm writing it the other way. 2x minus 1 is less than and equal to 11. Okay, so this is how we write. Again, this is an inequation. So we're going to solve for x by writing 2x is less than and equal to 11 plus 1. I've taken 1 to the other side. So now it becomes 2x is less than and equal to 12. So now we can find the value of x. X is less than and equal to 12 divided by 2, which is 6. So now we have this part, x is less than and equal to 6. So we have to write all the numbers that are less than and equal to 6, but keeping this point in mind that x belongs to natural numbers. That means natural numbers begin from 1. So let's write down the elements of set A. The elements of set A will be all natural numbers less than and equal to 6. So it will be 1, starting from 1. 1, 2, 3, 4, 5 and 6. So we have all natural numbers less than and equal to 6. Now let's solve for B. Let's find out what are the elements of B. Let's read this. Y is such that Y belongs to whole numbers and Y is greater than and equal to 3 but less than and equal to 9. So this we can write it directly. Y will be equal to. Now here it says Y is greater than 3 but also equal to 3. So we start with 3. So we start with 3 and we go on till which number? Here it says y is less than 9 but also equal to 9. So we go up to 9. So right from 3, 4, 5, 6, 7, 8 and 9. So we have the elements of set B. So those are the values of y. So let's write it down. 3, 4, 5, 6, 7, 8 and 9. Now the question is, are these sets A and B equivalent? Remember, equivalent sets are sets which have the same number of elements. So let's count here. 1, 2, 3, 4, 5, 6. There are 6 elements here. Here we have 6. Now here let's count and see. 1, 2, 3, 4, 5, 6, 7. So here we have 7 elements. That means these two sets are not equivalent sets. So we can write that not equivalent sets. So we have written that not equivalent sets. Let's go to the next one. Question 2. Set of integers and set of natural numbers, are they equivalent or not? Now set of integers. Now let's write the set of integers. So integers you can start from negative numbers. Instead, let's start with minus 3. Minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. And here also it goes on even before minus 3. Now the set of natural numbers begin only from 1. 1, 2, 3, 4 and it goes on. So it goes on indefinitely. So we can't count and say whether this and this are the same. Isn't it? The number of elements here and the number of elements here, we cannot say they are same because they are not finite sets. So here also these two sets are not equivalent sets. So we can write that these two sets are not equivalent sets. The third question here is set of whole numbers and set of multiples of 3. Are they equivalent or not? Now set of whole numbers. So whole numbers will start from 0. So 0, 1, 2, 3, 4. Again, this goes on indefinitely. And set of multiples of 3. So multiples of 3, if we have to write, it will be 3, 6, 9, 12, 15. Again, this goes on indefinitely. Whenever sets go on indefinitely, we are not able to count the number of elements, then we cannot say if they are equivalent or not. So these two sets also are not equivalent sets. So we can write it as not equivalent sets. Question 4, P is equal to 5, 6, 7, 8. So how many elements are there? There are 4 elements and M is equal to X is such that X belongs to whole numbers and X is less than and equal to 4. So we have to solve this. We already have the elements of set P, that is 5, 6, 7 and 8, and we know that there are 4 elements. Now we have to solve this. We have to find out this. Now X belongs to whole numbers means it can start from 0 and X is less than and equal to 4. So what are all the numbers less than 4? Whole numbers 0, 1, 2 and 3 and it's also equal to 4. That means M is equal to all the elements there, that is 0, 1, 2, 3 and 4. So here set P has only 4 elements and set M has 5 elements, as you can see. That means they are not equivalent sets. If they are equivalent sets, the number of elements should be the same. So we can write it this way and say not equivalent sets. Question 12. State whether the following pairs of sets are equal or not. Now what are equal sets? These are two sets which must have the same elements. So set A has 2, 4, 6, 8. If set B also has 2, 4, 6, 8, then we call them equal sets. So we already know the elements of set A. Now we're going to find out the elements of set B. So what does it say here? 2n is such that n belongs to natural numbers and n is less than 5. So first let's think of all the natural numbers less than 5. So n will be all the natural numbers less than 5, that is starting from 1. 1, 2, 3, 4. There are 4 elements because they're all less than 5. So this let's keep in mind. Now here it says that 2n is such that. So we have to find out 2n. So 2n will give us the elements of this set. So let's begin by saying when n is equal to 1. When n is equal to 1, then 2n will be 2 into 1, which is 2. Okay, so we finished with 1. Let's take 2. When n is equal to 2, 2n will be 2 into, what is n now? 2. 2 2s are 4. Now let's take 3. When n is equal to 3, 2n will be 2 into 3. 2 3s are 6. Now let's take the fourth one, that is n is equal to 4. In this case, 2n will be 2 into 4, which is 8. So these are all the elements of set B, 2, 4, 6 and 8. So let's write it down. So A is equal to 2, 4, 6 and 8. Now we have found the elements of set B also, and what are those? They are 2, 4, 6 and 8. That means the elements of set A and set B are the same. That means they are equal sets. So sets A, you can write that sets A and B are equal sets. So this is our answer. You need to find out and write your answer. These are equal sets. So this is our final answer. Question 2. M is equal to x is such that x belongs to whole numbers and x plus 3 is less than 8. That means we have to solve this and find all the elements of M. Similarly, we have to solve this and find all the elements of set N and see whether the elements are the same. Then we can call them equal sets. So let's begin with set M and solve this. So what does it say? X belongs to whole numbers and x plus 3 is less than 8. So let's take this part. X plus 3 is less than 8 and solve that. So x plus 3 is less than 8. That means x is less than 8 minus 3. X is less than 5. And here it says x belongs to whole numbers. So we have to write down all the numbers less than 5 starting from 0 because they are whole numbers. So we have found the elements of set M, that is 0, 1, 2, 3 and 4. So these are all the elements of set M, and follow this. X belongs to whole numbers, so we have 0, and we worked this out and we found out that x should be less than 5, so we've not included 5. Now let's find out the elements of set N. So here what does it say? Y is such that y is equal to 2n minus 1. So what is n? N belongs to natural numbers and n is less than 5. So what are all the numbers less than 5? Less than 5 will be, now because they are natural numbers and less than 5, it will start from 1. So 1, 2, 3 and 4. These are all the numbers less than 5. So keep this in mind. So this is n. Now we have to find out the value of y. Y is equal to 2n minus 1. So when n is equal to 1, y will be, now remember 2n minus 1 means 2 into n. 2 into 1 minus 1, which is 2 ones are 2 minus 1, that is 1. So the first element is 1. So we said when n is 1, we took this. Now let's say n is equal to 2. So when n is equal to 2, then y is 2n minus 1. That means 2 into 2 minus 1. 2 2s are 4. 4 minus 1 is 3. So the next element is 3. The next one we have to take this when n is equal to 3. So when n is equal to 3, y is equal to 2n minus 1. 2 into 3 minus 1. 2 into 3 minus 1. 2 3s are 6. 6 minus 1 is 5. So we have 5 here. Now let's take the last one, that is 4. So when n is equal to 4, when n is equal to 4, y is equal to 2n minus 1, where 2 into n is 4 minus 1. 2 4s are 8 minus 1 is 7. So these are the elements of set N. So let's write it down here. So set N will be, the elements are 1, what I've circled there, 1, 3, 5 and 7. So as you can see, the elements are different. Okay, we should have the same elements, only then we can call them equal sets. So here we cannot call them equal sets. So sets M and N are not equal sets. So we can write out our answer like this, saying sets M and N are not equal sets. Question 3. E is equal to x is such that x square plus 8x minus 9 is equal to 0. We have to solve this and find the elements of E. Now the elements of F are already given to us. If both the sets have the same elements, we can call them equal sets. So let's begin by solving for question E. So here we have x square plus 8x minus 9 is equal to 0, a quadratic equation. X square plus 8x minus 9 is equal to 0. Now, as always, look at this number. We have to think of two numbers that will multiply to give us 9 and add to give us 8. So let's think of 9 first. Let's start with 9. 9 will be 1 9s are 9. Okay, 3 3s are also 9, isn't it? So here this is minus 9. That means one of these should be minus. So let's find out here. Here we have 8x. Now, which of these here, when you add, you will get 8. 3 plus 3 will not give us 8. But here 1 plus 9 will give us 10. But if we can subtract it, it becomes 8, isn't it? So to get 8, we can take up the numbers. Now 1 plus 9, but if we put a plus sign here, it becomes 10. So we have to put a minus sign somewhere. If I put a minus sign here, this will become 1 minus 9, which is minus 8. But 8 doesn't have a minus sign, so we cannot put the minus sign for 9. We can put the minus sign for 1. Okay, so now let's see. So we have minus 1 plus 9, which is 8. Similarly, you can put the minus 1 here. So it becomes minus 1 into 9 is minus 9. So did you see that? So the numbers are minus 1 and 9. These are two numbers that we can use. So what have we done? We have split this up into minus 1 plus 8. So let's write this x square plus minus 1 minus 1x plus 9x. We can put it this way. Plus 9x minus 1x. So what have we done? This 8x, we have split it up into 9x minus 1x. Now we can write this. Minus 9 is equal to 0. Now here we're going to look out for the common terms. So here what can we see? Here there is x square, here there is x. So x is common. So I can take out x and in brackets I can put the remaining. Here there is x square and from that I've removed 1x, so I can put 1x inside. So this becomes x plus, now here we have 9x. From this x is already here, so I just have to put 9 inside. Then we'll write minus here, and what is common here? 1x and 9x is nothing common, so only 1. So let's write 1 here. Now inside what should I write? Minus 1, I've taken it out. So what is left is only x. I can write x. Now here I need to get a minus sign, isn't it? So if I have to get a minus sign, since I already have a minus sign outside, I should put a plus sign inside. If I put a minus sign inside also, it will become minus into minus, which is plus, and that is wrong. We need to get minus 9. So this will remain as plus, and this is plus 9, which is equal to 0. So this way, can you see you have x plus 9, x plus 9. So now take out the common ones. So first x plus 9 is removed. Then we can look at x minus 1. So this is x minus 1 and all this is equal to 0. That means this factor is equal to 0 and this factor is equal to 0. So let's find the value. X plus 9 is equal to 0. So x is equal to 0 minus 9 or x is equal to minus 9. So we found the one element of set F, set E. Now let's go to this part, x minus 1. So x minus 1 is equal to 0. So x is equal to 0 plus 1. So x is equal to 1. So we found the second value. So let's go back to the question here. So here we have E is equal to all this. We have just found out the values of E, 1 and minus 9. So we can write it here. The values of E are 1 and minus 9. So what are the values of F? F is also 1 and minus 9. So both the sets have the same elements. That means E and F are equal sets. So you can write out your answer like this. Sets E and F are equal sets because we found out that they have the same elements in them. Question 4. X is such that the set A, X is such that X belongs to natural numbers, X is less than 3. So we have to find the elements of set A. Similarly, we have to find the elements of set B. So let's find the elements of set A. Now here it says clearly that x belongs to natural numbers. That means it starts from 1 and x is less than 3. So that's easy, isn't it? So starting from 1 less than 3 means 1 and 2. Only two elements. Now we have to solve this and find out the elements. So let's do that. So that is y square minus 3y plus 2 is equal to 0. Again, here we need to think of two numbers that will multiply to give us 2 and add to give us minus 3. So let's do this. 2 is equal to, now what are the numbers that will multiply to give us 2? 1 into 2. So when you say 1 into 2, you get back 2. Now will we get minus 3? So here if I say 1 plus 3, what will I get? I will get 4. That's 1 plus 2 children, not 3. 1 plus 2 will give me 3, isn't it? But here, as you can see, I need to get minus 3. So how will I get minus 3? If both these signs are minus, I will get minus 3, isn't it? So let me change the signs here and see. So here, if I say minus 1, minus 2, what will my answer be? When signs are the same, we put the same sign and we add, it becomes minus 3. And if I put the minus signs here also, minus 1 into minus 2, I will get minus into minus plus 1 into 2 is 2. So my numbers are minus 1 and minus 2. Minus 1 and minus 2 because if I multiply, I will get 2. If I add, I will get minus 3. So we are going to split 3 minus 3y into minus 1 and minus 2. So let's write that. So y square minus 1y minus 2y plus 2 is equal to 0. Now let's pick out the common term from these. So here there is y square and y, that means y is common. So I can take y out and inside, since it's y square, I can put 1y here because there's 1y already outside. Minus, now here I have 1y, this y is already here. So I just have to put 1 inside, 1. Now let me go to the other part. I can see what is common here. 2 is common. Can you see 2 is common? So let me take out minus 2 and keep it out. So minus 2. So if I take out minus 2, what is left inside? Only y is left. So I can put y. And here, since I already have minus 2 here, if I have to make it plus 2 inside. Now 2 is already there. So I don't have to put 2 inside. I have to put 1 because minus 2 into 1 should give me minus 2. But this is plus. Because it's plus, I have to put a minus sign here, minus 1. Now here, as you can see, minus 2 into minus 1. Minus into minus is plus, 2 into 1 is 2. So I will get back this. So these are my common factors. Let's bring out the common ones, y minus 1 and y minus 2. And all this is equal to 0. So now we can calculate y minus 1 is equal to 0. That means y is equal to 0 plus 1. Y is equal to 1. So I have solved this and I have found the value of y here. Y is equal to 1. Now let's take up this one. Y minus 2 is equal to 0. So y is equal to 0 plus 2 or y is equal to 2. So I've got the value here also, y is equal to 2. So now what does that mean? It means that I found the elements of set B. And what are they? The elements of set B are 1 and 2. So let's write it here, 1 and 2. So now as we can see, set A and set B have the same elements 1 and 2. That means these two sets are equal sets. So we can write that sets A and B are equal sets. Question 13. State whether each of the following is a finite set or an infinite set. So what is a finite set? A set which has a limited number of elements, whereas an infinite set is a set which does not have a limited number of elements. That is, the number of elements keep going on and on. Now the set of multiples of 8. So let's write the multiples of 8. What are the multiples of 8? 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32, 8 fives are 40, and so on. This goes on and on. So that means this is an infinite set. So So we can say that the set of multiples of 8 is an infinite set. Next one, the set of integers less than 10. Set of integers less than 10. Okay, now if we have to write integers less than 10, so we'll start from 9, 8, 7, 6, 5, 4, 3, 2, 1. Remember, these are integers, so I can use 0 and I can use negative numbers. -1, -2. That means this goes on and on. So this is not a finite set. This set of integers less than 10 is also an infinite set. So we can write that this is an infinite set. Question 3, the set of whole numbers less than 12. So let's write out all the whole numbers less than 12. So 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0 because it is a whole number. Now this set, as you can see, has a limited number of elements. So this is a finite set. So we can call this a finite set. Fourth one, x is such that x is equal to 3n minus 2. And what is n? N belongs to whole numbers and n is less than and equal to 8. So n, let's write out all the values of n. N belongs to whole numbers, so we start with 0 and it's less than and equal to 8. So we write all numbers up to 8. 1, 2, 3, 4, 5, 6, 7 and 8. So now we have to find the value of x, and here it says x is equal to 3n minus 2. So we're going to do this. X is equal to 3n minus 2. Let's keep that here, 3n minus 2. So now we're going to start taking the values of n when n is equal to 0. So when n is equal to 0, x is equal to 3n means 3 into 0 minus 2. That is 3 into 0 is 0 minus 2, which is minus 2. So we have found the first one, minus 2. Then we finish taking 0, let's take 1. So when n is equal to 1 this time, when n is equal to 1, x is equal to 3n, remember? So 3 into 1 minus 2. 3 ones are 3, minus 2 is 1. So we have the next element. Next, we'll take 2. When n is equal to 2, when n is equal to 2, x is equal to 3n. That means 3 into 2 minus 2. That will be equal to 6 minus 2. 3 twos are 6 minus 2, which is 4. So we've got our next element. Then we go to n is equal to 3. When n is equal to 3, x is equal to 3n. So if you continue in the same way when n is equal to 1, 2, 3, 4, 5, 6, 7 and 8 and you work this out, these are the elements you're going to get. So what are the elements of this set? Minus 2, 1, 4, 7, 10, 13, 16, 19 and 22. So these are all the elements that I've taken from here after calculating all this. And these are the elements. As you can see, there are a limited number of elements. That means this set is a finite set. So we can write that. So the answer can be that this is a finite set. The fifth one is x is such that x is equal to 3n minus 2. N belongs to integers and n is less than and equal to 8. So here less than and equal to 8. So all numbers less than 8 and equal to 8. So let's write what n is. So n is equal to 8, 7, 6. Now look at this part. It says n belongs to integers. That means I can put 0, I can put the negative numbers. So let me continue. 5, 4, 3, 2, 1, 0, minus 1, minus 2. I can go on and on, isn't it? Negative numbers. So here, if I have to find this value, x is equal to 3n minus 2. So it will be x is equal to 3n minus 2. We're going to use that. Now, when n is equal to 8, if I start with 8, when n is equal to 8, then 3n minus 2 means 3 into 8 minus 2. 3 8s are 24 minus 2 is 22. Now when n is equal to 7, so I've taken 8, now I've taken 7. When n is equal to 7, then this will be equal to 3n. That means 3 into 7 minus 2. 21 minus 2, which is 19. Now when n is equal to 6, so 3n will be, in that case 3n will be 3 into 6 minus 2. 3 6 are 18 minus 2 is 16. When n is equal to 5, this will be 3 into 5 minus 2, which is 3 5s are 15 minus 2. 15 minus 2 is 13. So let's write 13 there. This is 13. Now this will continue. This n will continue because here it says 5, 4, 3, 2, 1, 0, minus 1, minus 2. It will keep on going. That means these also will continue to go. So the elements here you can start with 22, 19, 16, 13. But this n is going to continue. It will keep going on and on. So this is an infinite set because it is indefinite. The number of elements are not finite, it's not limited. So this is an infinite set. We can write out our answer this way. Question 6. X is such that x is equal to n minus 2 by n minus 1 and n belongs to whole numbers. Now whole numbers, so that means n is equal to starting from 0, 1, 2, 3 and so on. So this itself is giving us a hint that this is going to be an infinite set because the number of elements are unlimited, countless. So if we have to work this out, so in that case when n is equal to 0, then x is equal to n minus 2. That means 0 minus 2 by n minus 1, that is 0 minus 1, which is minus 2 by minus 1. So here, what does this become? The minus signs get cancelled. 2 by 1 is 2. So we've got the first element, which is 2. Now what happens when n is equal to 1? So similarly, we are going to get many elements because here there are many elements. So we're going to continue to work this out and we'll keep getting many elements here. So that is going to be unlimited. That means this is also an infinite set. You don't have to work out everything because it's understood that it's going to be an infinite set. So we can write that out, infinite set. Question 14. Answer whether the following statements are true or false. Give reasons. The set of even natural numbers less than 21 and the set of odd natural numbers less than 21 are equivalent sets. What's the meaning of equivalent sets? They are sets which have the same number of elements. So let's look at the first part, the set of even natural numbers less than 21. Let's write that. What will be the even natural numbers less than 21? Let's begin. Natural numbers begin with 1, but we are talking about even numbers. So 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20, less than 21. So we have so many. So we have got the set of even natural numbers less than 21 here. Now let's see the set of odd natural numbers less than 21. So let's write that starting with 1. 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19. Less than 21, so we stop at 19. Now we have to count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have 10 elements. Let's count here also and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here also we have 10 elements. So that means this statement is true because these two sets are equivalent sets. So let's write that. True because both the sets have 10 elements each. They've asked us to give a reason also. So we've given the reason that they are equivalent sets because they have the same number of elements, 10 elements each. Question 2. If E is the factors of 16 and F is the factors of 20, then E is equal to F. When do we call two sets equal? When they have the same elements. So let's find out the factors of 16. The factors of 16 are the elements of E, isn't it? So that will be 1 into 16 is 16, 2 8s are 16, 4 4s are 16. So 2 8s and 1 into 16. These are the factors of E. What are the factors of F, that is the elements of F, will be all the factors of 20, that is 1 into 20, 2 tens are 20, 4 fives are 20. So 2 into 10 and 1 into 20. These are the factors of 20. Now here you can see the elements are different. Only 1, 2 and 4 are the same. All the other elements are different. So we cannot call them equal sets. So this statement is false. False because E is not equal to F because the elements of the sets are not the same. When they are the same only, we call them equal sets. Next one, set A is integers less than 20, and it says that this one is a finite set, integers less than 20. So let's see if you have to write the elements of set A. What are all the integers less than 20? We can start with 19, 18, 17, 16, 15, 14. It goes on and on. We can go up to 0. Integers means negative numbers also. -1, -2. This also goes on and on. So is this a finite set? It's not a finite set. So this statement is false. Why? Because this is not a finite set. This is an infinite set. Question 4. If A is equal to X is such that X is an even prime number, then A is empty. So here they're saying the elements of set A are even prime numbers. Are even prime numbers, even numbers prime numbers? Only the number 2 is an even prime number. So in set A, there is one element, whereas this statement says that set A is an empty set. So this statement is false. Set A is not an empty set. The elements of set A will be 2. So I can write it here. There's one element in set A. So the statement is false. This is not an empty set. Question 5. The set of odd prime numbers is an empty set. Okay, so what are the odd prime numbers? That statement is false because the set of odd prime numbers will be 3, 5, 7, 11, 13. As you can see, these are all odd prime numbers. So this statement that it's an empty set is false because the set of odd prime numbers are these and it is not an empty set. Question 6. The set of squares of integers and the set of whole numbers is saying are equal sets. So let's see. What are, this statement is false. Why? What are the set of squares of integers? Now, integers can be -3, -2, -1, 0, 1. It can go on and on and on. Okay. So here it says the squares of integers. So -3, if I say -3 square, it is minus into minus is plus, 3 3s are 9. Then I say -2 square, plus minus into minus is plus, 2 2s are 4. Then again I can say -1 the whole square, minus into minus is plus, 1 1s are 1. So this goes on and on. Here I've just written a few elements, but this goes on and on and on. So I will close my brackets here. Now the set of squares of integers are these numbers. Now what are the set of whole numbers? The set of whole numbers are 0, 1, 2, 3 and so on. So as you can see, the elements are different. So they are not equal sets. So the statement is false. So these sets are not equal sets. The elements are different, so they're not equal sets. So with this, children, we come to the end of this exercise. Thank you, children.